James Webb and the strange objects challenging our picture of the early universe. A few years ago, astronomers began looking farther into the universe than humanity had ever been able to see. The James Webb Space Telescope was designed to study some of the earliest galaxies and stars, allowing scientists to observe light that has traveled across space for billions of years. What Webb found was not simply a clearer picture of the early universe. It revealed a universe that appears far more complicated, crowded, and surprising than many researchers expected. The standard cosmological model, commonly known as lambda-CDM, has been remarkably successful. It describes the expansion of the universe, the role of dark matter and dark energy, the formation of galaxies, and the growth of cosmic structures over time. It has survived countless observations and remains the foundation of modern cosmology. But the model also makes predictions about the young universe. In the first few 100 million years after the Big Bang, matter should have been gradually gathering under gravity. The first stars were forming, small galaxies were beginning to assemble, and black holes were starting their growth. Massive modern galaxies and enormous black holes should have been relatively uncommon because there simply had not been enough time for them to develop. Then Webb began observing this ancient era. Among its earliest discoveries was a mysterious population of compact, reddish objects that astronomers eventually nicknamed the little red dots. They were extremely distant, meaning we were seeing them as they appeared when the universe was very young. Many were surprisingly compact and bright, and their spectra contained features associated with rapidly moving gas around energetic sources. At first, some interpretations suggested that these objects might contain enormous black holes. That immediately created a problem. A black hole can grow by consuming surrounding material, but there are limits to how quickly that process can occur. If a black hole begins with a relatively small seed, growing it into something millions or hundreds of millions of times more massive than the Sun in only a few 100 million years is extraordinarily difficult. The situation was therefore compared to finding a fully grown tree in a garden where the seed had supposedly been planted only days earlier. However, science rarely moves from an unusual observation directly to a revolutionary conclusion. Astronomers began examining every assumption behind the original measurements. One important issue involved the gas surrounding the suspected black holes. When gas is moving at enormous speeds, the emission lines in its spectrum become broadened. If those lines are interpreted too simply, the central black hole can appear substantially more massive than it really is. Later analyses suggested that some early estimates may indeed have been dramatically inflated. That was an important reminder. An observation can be real while its first interpretation is wrong. Instead of proving that cosmology was completely broken, the little red dots might represent a population of objects that scientists had simply failed to recognize before. And that possibility leads to one of the most fascinating ideas surrounding these objects. Imagine a black hole surrounded by an enormous dense cloud of hydrogen. The black hole is pulling material inward and releasing huge amounts of energy as that material falls toward it. From a great distance, the surrounding gas could make the entire system resemble something much more like a glowing stellar object than an ordinary black hole. In this scenario, the object would not actually be a star. It would be a black hole hidden inside a brilliant cocoon of gas. Such a system could potentially explain why these ancient objects appear so compact and unusually bright while also producing spectral signatures associated with energetic black hole activity. But another possibility is even more exotic. Some researchers have suggested that at least part of the little red dot population could represent an entirely different stage in cosmic history: extremely massive stars. These would not be stars comparable to our Sun. They would be hypothetical monsters containing tens of thousands or even hundreds of thousands of solar masses. The idea of extremely massive stars has existed in theoretical astrophysics for years. In the early universe, the conditions were very different from those found inside modern galaxies. The first generations of stars formed from material dominated by hydrogen and helium, before later generations became enriched with heavier elements. Under certain conditions, enormous clouds of primordial gas could potentially collapse into exceptionally massive stars. Such stars would be unstable and short-lived. Their lives could end in violent collapse, potentially producing the massive black hole seeds that later grow into the supermassive black holes found at the centers of galaxies. If astronomers were somehow observing such objects directly, they would be seeing an extraordinary moment in cosmic history. They would not simply be observing ancient stars. They could be witnessing one of the processes that eventually created the giant black holes that dominate the centers of galaxies. Part 2. The mystery gets deeper. The first surprise from the early universe was that Webb was finding objects that appeared far too mature for their age. But once astronomers began studying these strange objects more carefully, another possibility emerged. Maybe the problem was not that the universe had somehow built enormous black holes too quickly. Maybe we were looking at a completely different kind of object. This is where the mystery of the little red dots becomes even more fascinating. These objects are extremely compact, incredibly bright, and often surrounded by unusual spectral signatures. From a distance, they can look almost like tiny stars. But there is something very strange about their light. The spectrum contains clues that suggest enormous amounts of gas are moving at incredible speeds. That is exactly the kind of environment scientists expect around an actively feeding black hole. A black hole itself does not shine. But the material falling toward it can become extraordinarily hot and release enormous amounts of radiation. The closer gas gets to the black hole, the more extreme the environment becomes. And if enough material is falling inward, the entire system can become brighter than a galaxy containing billions of ordinary stars. Now imagine this happening in the early universe. A relatively young galaxy contains a black hole seed. Gas begins falling toward it. The black hole grows. But instead of seeing a clean, exposed black hole, astronomers may be seeing the object buried inside an enormous cocoon of gas. That cocoon changes everything. It can absorb and reprocess radiation. It can make the object appear larger. It can alter the spectrum. And from billions of light years away, it may make the entire system resemble a strange glowing star. This could explain why the little red dots were so difficult to classify. They are not necessarily ordinary galaxies. They are not ordinary stars. And they may not look like the familiar quasars we see in the modern universe. They could represent a short-lived stage in the evolution of some of the earliest black holes. But there is another possibility. What if the central engine isn't a black hole yet? What if it is an enormous star? Scientists have theorized about extremely massive stars that could have existed in the primordial universe. These hypothetical stars would have been radically different from the stars around us today. The early universe contained almost no elements heavier than hydrogen and helium. That changed how gas could cool, collapse, and form stars. Under unusual conditions, enormous amounts of gas might have collapsed into a single object. Instead of producing a star with a mass similar to our Sun, the process could potentially create something tens of thousands of times more massive. Such a star would be incredibly unstable. Its interior would experience extreme temperatures and pressures. It could burn through its fuel at an astonishing rate. And its lifetime might be extremely short compared with ordinary stars. But that short life could have enormous consequences. When such an object finally collapses, it could potentially leave behind a massive black hole seed. That creates a fascinating possibility. The little red dots might be showing us the transition between giant primordial stars and the first massive black holes. If that is true, Webb is effectively looking at the birth of one of the most powerful objects in the universe. But there is still a major problem. How do we know which explanation is correct? The answer lies in the light. Astronomers can break distant light into a spectrum and look for fingerprints. Different physical processes leave different signatures. Stars produce particular combinations of absorption and emission features. Hot gas around black holes produces another pattern. Chemical elements create specific spectral lines. Even the motion of gas leaves information behind because movement changes the wavelengths we observe. So astronomers are essentially performing forensic science on light that has traveled for billions of years. And the more detailed the observations become, the more useful those fingerprints are. This is why future Webb observations are so important. A single blurry point of light can support several explanations. A detailed spectrum can eliminate many of them. If astronomers detect patterns that clearly indicate rapidly rotating gas around a central black hole, the black hole interpretation becomes stronger. If they find chemical signatures expected from an enormous stellar interior, the massive star explanation gains support. And if both signatures appear together, scientists may discover that the truth is more complicated than either model. There may not be one answer. There may be several kinds of little red dots. That would actually make the situation even more interesting. Because it would mean that the early universe was already producing multiple pathways toward massive black holes. Some could have begun with the deaths of enormous stars. Others might have formed directly from collapsing gas. Others could have grown rapidly inside dense environments. Different mechanisms could have operated at the same time. And eventually, some of these early black holes may have grown into the supermassive